So let's dive into part 2 of the segment 1 session. So moving ahead with the session, the title is Extracting Features, Building Roads, etc. and Detecting Changes from Satellite Energy. Before moving ahead, I would take this opportunity to introduce Mr. Krishna Rao TV. He is a Vice President at ISRI India Technologies with 26 years of experience in GIS and remote sensing. He specializes in driving enterprise digital transformation and business strategy, focusing on government utility, defense, and smart cities across India and neighboring countries. And Ms. Saranya M is a manager for pre-sales at ISRI India, leading the data science team since 2019. She holds a master's in environmental energy, engineering and management, and a PhD in RS and GIS. Certified in Desktop Associate and ArcGIS online administration, she focuses on Geo AI application across utility, defense, and government sectors. So I would like to invite Mr. Krishna Rao TVB and Ms. Saranya M. Please.
Hello. Thank you.
Thank you.
Good afternoon, everybody. Welcome to the post-lunch session. I know it's difficult, but we'll try to keep you awake and keep you engaging. So this is the session title which was given to me about how can we build a better urban frames using satellite and the geospatial data. So towards this, let's use this Geo AI, where one of the things how it can help you in doing extracting the features or detecting the change within the imagery. So in the morning, we would have heard from various speakers like we need to have a common data model. There are some of the point of interest, all which has to be finalized, and then the AI which has been talked a lot. So towards this, the RGIS, the Geo AI, how it can help you. So when you look into the AI part of that, this is very important in identifying the areas of growth, and this particularly is driving this whole exercise what we are trying to discuss in next 2 days. So one of the things which is there is the land use classification, how quickly. So these are all something which are being there. So is AI going to help you drive this do faster is the key. These have been there traditionally. These are nothing new. All these topics which I have written here are being done traditionally using the geospatial softwares. But where AI is going to help you is reduce the dependence on the huge manpower which is going to be involved in these exercises. Can it help optimize that? Can it help identify these changes quickly? And then give a better planning exercise. That's where this whole story of AI comes into the game. So this being there, so what is AI is basically an advancing science of GIS with AI, and what are those possibilities? So you all would have heard about computer vision models coming into AI. This is something when you are talking about remote sensing data sets, the computer vision model plays a very important role, and they work with imagery, 3D and the video data sets. Whereas the NLP models are working on your unstructured data. Whereas the machine, so that's what and these tools actually are helping you doing the automatic data extraction. So you can think the kind of time or the savings it is going to bring you, the manual efforts it is going to reduce. Similarly, there are machine learning and deep learning tools for vector, tabular, time series, and multi-temporal imagery. And then these are used to basically uncover many of the insights. So all of you who are in the space of AI, who understands this, so one of the key aspects will be to build a model which runs on different types of data sets. So we at ISRI understand all this, and that's why we have already launched many ready-to-use pre-trained AI models. It is available through our platform for accessing. And you can see some of the things which are highlighted in white. You can see these are something which would be of interest to you or to this particular objective of MoSPI, what they want to achieve in. So these are something which are out of box. These models are there, trained with the global data sets. you can run on the Indian data sets and we can fine tune them. And we are very happy to announce that we have already released the building footprint extraction model for India. It's available through our Living Atlas, and this is something which you can test it out. The other interesting evolution which has happened in the AI segment is earlier on to your left, you can see these are all very task-specific pre-trained models which are there. So like I want to do a building footprint extraction, I have a separate model. For water body, I have a separate model. I want to do a change detection, there is a separate model. All of these are there. But nowadays the trend is coming into prompt base. And that's how the generalized pre-trained models have come. And thanks to the LLM, which has been playing a vital role. So at ISRI, we are able to provide you an integration with models like Llama, ClipSec, GPT, DNO, and all of Clip. So, and there where you give a prompt. So for example, you want to say, find me all buildings in the provided imagery. This model helps use the computer vision model in the background and tries to extract and give it to you. So there is so that's where I'm giving, that's what is coming through your text SAM. You're giving prompts. So we have another model of SAM which comes from Meta. It can segment anything on the image, but now it's up to you to classify and make it intelligent, whether it's a building or a road or water, whatever it is. And that's where the whole, the change which is coming in, and that's where we stand out from the industry as ISRI. We provide you all of these things very quickly onto the platform. So there are multiple facets of a building footprint extraction. You can see this is what is rural. So you have a scenario of a semi-urban, and then you have an urban scenario. I'm sure you would have seen this in many satellite images, the scenario, how it is changing. And then you have an undulating terrain. And then you have an informal settlements. That's another risk. So look like areas like Dharavi or other slums where the classification of building could be very challenging. So a solution which has to be there should be able to do all of these things quickly. And that's where the beauty of a model can come in. So this is the workflow. Like similarly, how we have done for buildings. You can see this, which what we can do for your field boundary extraction to roads, which can be doing in. So all of these are available, which can be tested and tried with your thing. So here you can see the next comes the changes. In the morning, there are a lot of things which are there where you want to detect changes in the AI. And this is where you can see there is an image from 2017 to 20 when you compare the new construction would have come. And this is where the new detection can happen. So again, this is not restricted only to this. This is also, you have so much large programs going on government where you are trying to see the new assets or the illegal occupation of the government as lands being done. These kind of tools are actually helping them to do this. Apart from that, we can do many of those normalizations through the large language models where I can do another challenges which definitely MoSPI would be in is standardization of your data sets. So you can see on your left the input raw data. Somewhere Bangalore is written as BLGR. But do you need a standardization across it for integration with across the various systems, right? The MoSPI data is not limited only to MoSPI. It is contributing to various other organizations for planning. Like, for example, you're giving it to NITI Aayog and others. So that's where the standardization is very important. That's where, again, the LLM integration into the RGS actually is helping you do all these standardizations. And we provide these tools out of box. And the other interesting one is to have a 2D to 3D. In the morning, we have seen all of people talking about 2D to 3D, but with our platform, you can also see how you can see the central, that's a high resolution 5-angle camera drone images, which has been taken for the place of Delhi. And on the left, you can see a 2D building extraction. On the right, you can see the actual 3D of that. And all happening within the GIS lab. And this is how you can do this maintenance, and this is how this data can become one of the key factors of the AI, how it can help you in doing all your planning work or generating your EB. So my colleague Saranya will show you a small demo about how this is happening, what I've talked, let's see on the action, and then followed by a very interesting demo from my colleague Kate, where you can see how she's automating an EB generation out of these extracted features.
Thank you, Krishna sir. Good afternoon, everyone. So, Krishna sir discussed about lot of pre-trained models. So this is the page where you will get access to all the models. So livingatlas.arcgis.com, you can see there are over 90 plus models available now for various different features of interest like roads, buildings, trees, etc. And if you want to use any of them, you can download them from this page and use it immediately. Now let's take a look at one of the model, text SAM. So this is a generalized model which can take text prompts and give you the feature you want. You can specify the object or explain the object you want to extract from the imagery and it will do it. Let us see one quick demonstration of that. So here I am in Mangalagiri region in Andhra Pradesh and I would like to extract all the buildings. So to make my detections accurate and just to ensure that none of the buildings are left behind, I can give different keywords as text prompt. So here I am mentioning tin, grey, roof, rooftop, shelter, house, building, structure, etc. So when you do this, the model automatically gives an output like this. So this actually saves us a lot of time we put in manually digitizing the building footprints. So you will find these tools in the image analyst extension. The second model I would like to discuss today is building footprint model for India. So this model was trained on high resolution imagery and it is expected to work in urban areas like Hyderabad, Nagpur, etc. Let us take a look at the output. So here I have 0.5 meter imagery of Nagpur city. And I can call this model from classify pixels using deep learning. I have called the building footprint extraction model for India. This automatically gives me a raster of all the settlements it has detected here. And you can do post-processing to regularize the building footprint so that you have the vector data that you want. The another model is SAM. So this is actually released by Meta, formerly known as Facebook. So this model is very good at detecting everything and anything in a given imagery so that you can use this as a base model to train your own model for buildings or field boundaries or trees. Just to give you a quick look of how the output would look like. So like you see here, it is trying to delineate all the objects it sees in an imagery. I can use this to label or create my own field boundary model or a tree extraction model. And earlier we saw about the building footprint extraction model for India in Nagpur. So this model performs well in challenging terrains as well, because when the terrain is very undulating, it can be challenging to detect all the buildings. Chances are we could miss some of the buildings. And when we train a model, it is essential, we have to ensure that we cover different types of geographies, different diversity in, we need to have a lot of variance in our samples. Next, we'll take a look at one urban area. So one of the challenge in urban area is the buildings are too contiguous. It's very difficult to understand where one building starts and another ends. So in this case, it is good to have supplementary data sets like DSM. So when you look at the true ortho, it is little difficult to see which building starts where. But when I add the DSM layer, the differentiation kind of comes up. Now I'm able to differentiate the foreground from the background. So models like SAM can very well pick up on this and you can get better detections here. And we have a tool called extract LOD2 buildings, which Krishna sir also discussed earlier. So using that, you can automatically get a 3D view of the buildings. So you can quickly move from your building footprint, take the help of DSM and get a 3D building of the same. And finally, when we are working with data sets, especially when we are working on foundational GIS, it can be very time consuming to keep them updated especially when the area is constantly changing. So this is a location in Wayanad where a landslide happened last year, which drastically changed the geography and the environment here. So I may have to update the entire foundational GIS. For that, I can use tools like extract features using AI models, where I can call all the models in one go instead of extracting them one by one. So here I'm using road extraction model, high resolution canopy height, land cover classification, also a building footprint extraction model. And this also allows you to do any post-processing workflow you would like to carry out. For example, here I'm doing a polygon regularization workflow. So this tool automatically gives me all the layers in one go, which saves a lot of time. The next workflow I wanted to discuss today was change detection. So when we do a traditional change detection, it picks up all the changes in an imagery. Even if a tree has come up, it kind of marked as a change. But with AI, you can do focused change detection. You can train the model to only identify the objects that you want. So here we have trained a change detection model that only detects what are all the new settlements or new buildings that have come up in a given area. So here I have image from two different time periods. This is a before imagery and after imagery. And when you run the model on this, it kind of highlights the locations where new buildings have come up. And you can also create your own model or fine tune a model for your geography. So here we have done it for Hazira. You can see that you get a change polygon as an output, which detects all the changes that have happened. So with a combination of pre-trained models and out-of-box tools, you can create your own models. And coming to the last part of my demonstration, one of the challenge people face when working with building footprint extraction or identifying how many houses are there in a given area, informal settlements do pose a lot of challenge. So this is where models like SAM can help us. But as we discussed earlier, SAM detects everything or segments everything in an imagery. So we have added a new component or a capability called LoRa, which is low rank adaptation, with which you can fine tune SAM models with a handful of samples and automatically generate all the building footprints in a given area. So to summarize, we saw how we can use AI models to automatically detect buildings using prompts, or you can have a task-specific model like building footprint extraction. You can have models that work well on different terrains. You can add other data set as supplement. So you can have your own model with multispectral data as well. And you can use powerful tools to automatically run inferencing on multiple models. You can carry out change detection. And finally, you can also create your own model that can help with your problems or any model that can fit your use case. So that's all from my side. Thank you for your time.
Any question we have?
Not a question, clarification. Yeah, fine. Yeah, thank you. Whether it results in some sort of infringement in the privacy of the objects, whether it's a person or my property. As I dislike to be photographed without my permission, I dislike my property to be photographed without my permission also. That could be a case. I'm not telling. I just want to know, is there any legal provision or there is no legal provision exist to run a drone, take the photograph of my property, put lat long, and let others know this belongs to Mr. XXX or whatever it may be. So how do we protect the privacy, or there is no question of protecting the privacy, no legal provision exists for this. So any area can be photographed, any building can be photographed, it can be classified residential, commercial, or some other things. If you can tell something on it, yeah.
Hello, good evening. I just retired from Indian Air Force. I was looking after the security clearance of aerial photographs and maps. There is an open space policy. Any category can take any satellite imagery from any part of the world. Recently, in 2019, Government of India has cleared aerial photography, drone photography can be taken in any part of the India except defense establishment. That is all. Before 2019, there was a policy which I was looking after. Any aerial photography has to be cleared by Indian Air Force, Directorate of Intelligence and Ministry of IB. That's all. Anything more?
No, thank you, sir. I think
And for your side, sir,
yeah, I think
your products are slightly expensive. None of the Government of India ministry is using. Most of
I
us
think it's a
started
very
using ISRO or ADRIN-based software for development of their own, especially Ministry of Defense, Ministry of Home, DIPAC, NSCS, even Office of Deputy NSA is using all products supplied by NRSA or ADRIN. What is your role in reducing the cost of your products?
I think you have given a very general statement, sir. All the offices which you have mentioned are already using our software.
I already mentioned I am speaking only on the behalf of Ministry of Defense.
So even within the Ministry of Defense, there is a big utilization of the product where critical requirements of the product is there. That's already being used. And I think this discussion is not about the license who is using it. That's a different discussion. We can discuss that separately.
Reference,
yeah,
I talked.
Yeah, and answering to your question, sir, I think there is a remote sensing data policy which was already released by Government of India along with the geospatial policy. So all the images to be captured and all have to be governed within that. So I think in the morning there was a geospatial policy presentation which happened where he mentioned about what to be shown, what has to be hidden, and all that. So all of those things are governed within that. I think with the new open policy which this government has initiated, anything above 50 centimeter is open. You can take from thing and can be kept it out. Anything lesser than that has to be kept within the Indian region. So that I think the policy is very clear. As far as the privacy concern, I think there is nothing called, there is no law which says that you can't map this house and all, because if we are paying a property tax of a house, that means the municipality or the urban local bodies are likely to map you for the revenue purposes. So I think there is no law that we can't map a particular house or building. Yes, the restrictions are still there for the defense and other
Only defense sectors.
Yeah, only the defense and
atomic energy power.
Atomic energy and some VIP areas are also being restricted.
Not to be aerial photographed.
Yes, right. Yeah, thank you.
Thank you, Mr. Rao and Ms. Sonia.
Yeah, just I would like to add one more thing. So as you rightly mentioned, some users do worry about the privacy concerns. So whenever they are creating an application using such high resolution imagery, they do use algorithms like face blurring algorithms, or if they are showing any image of cars there, they can blur the license plate numbers. Those type of blurring or reduction algorithms are also available. So if a user would like to incorporate those tools are already available. Thank you.
Thank you. So moving ahead, Ms. Kate is already on the dais. So the next session would be on using geospatial data for developing urban frames and stratifications of areas. So Ms. Kate, please. Thank you.
Thank you. So now I'm going to talk about how we can use the extracted building footprints. So these are the same ones that Saranya was just showing extracting. And we're going to take those and use them to automatically create enumeration areas or sampling frames. So you can see we have a number of different tools here to work with vector data. And I'm going to be going into the territory design tool set. And I won't spend too much time talking about particular tools. I want this to be about the methods in general. But the idea here is that you can create a territory solution, and this is going to take as an input just your point or polygon features. So in this case, I'm using the building footprints, but this tool also would work if you have pre-digitized block groups. So if you've manually created specific blocks and you want to organize those into a sampling frame, you could run these same tools on that type of input as well. Or if you have building footprints extracted in some other means rather than going through the building footprint extraction. So a number of different ways that you can get started with a tool like this. So I have as my inputs the building footprints. I've also included as an input here roads, in this case from OpenStreetMap, but you're able to do road feature extraction, as Saranya was showing, from the imagery itself, or use any other authoritative data set. And then I've also brought in boundary data for the boundaries of the villages so that I can make sure that all of my sampling frame or enumeration areas nest within those administrative boundaries. So going into the territory designs tools, I can add variables to my analysis from the building footprints themselves. So in this case, I have the number of units. So I'm going to do a summary of the number of units in each building. So for each building, in this case, we've just generated that some of them have 1 unit, some of them have more than 1 unit, and we want to take that into account when dividing them up into the enumeration areas. Because obviously, if one enumerator is given multiple 20-unit apartment buildings and another is given multiple single-family homes, it's going to take them a different amount of time to complete that work. So we want to account for that right from the beginning. And that's one of the benefits of starting at this building level when you're creating enumeration areas, is you can get that finer level of detail that's going to help everyone complete their surveys in the same time frame and make the whole process as efficient as possible. So in this case, I'm balancing on the number of units in each building, as well as the number of buildings themselves. I can also include distance parameters. So in this case, I want a maximum territory radius of 700 meters. If I had a network data set, I could include that so that I would also be able to take into account traffic, the actual physical travel time for the enumerators from one side of their enumeration area to the other, or between the buildings that they've been assigned. I can also include barriers. So in this case, I've added 2 types of barriers. I've included polygon barriers, which are going to be those India village boundaries, so making sure that all of the enumeration areas fall within those boundaries. And then I've also included the major roads and highways, so that none of the enumerators are going to have to cross major roads as they're doing their data collection. The final step was balancing the variables. So I wanted to make sure that I had my maximum, minimum, and ideal values set for my specific constraints. So in this case, I set it that I want each of these output enumeration areas to have about 200 units to survey, and looking at approximately 150 buildings. And I weighted the units more heavily than the building total, since that's what's really going to impact the time it takes them to do the surveys. So I'm doing all the work up front here with setting the parameters, and then I can just let the model run, and it's going to automatically create my enumeration areas. So the last step here is to select solve. There are a number of different algorithms that we can use based on what we want to prioritize. So in this case, I did optimal max coverage. So it's creating whatever number of territories it needs in order to have each one with approximately 200 units. But there are other options. If you have a very strict number of enumerators you know you can hire, you can do a user-defined number of territories that you'll generate. And when I go ahead and run this, the output sorts all of those buildings into a different enumeration area. So you can see that they're all clustered close together. And this is just the direct output from the tool. I haven't done any editing to it. And you can see that they're respecting the boundaries that I provided with those major roads. And I can also do additional validation. So if I open up the Modify Territories option, it's going to show me that there's varying numbers of buildings in each of these different enumeration areas. And that's because of the variety in the number of total units associated with each building. So some of them have multiple 20-unit buildings, So there are going to be fewer buildings included in that enumeration area. But you can see almost all of them amount to around 200 total units. And I could have set this to be stricter if I needed it to be exactly 200 units. I could have adjusted those minimums and maximums. But the output here is solidly within the limits of what I set as the inputs to the model. And the other nice thing is these outputs are just normal polygons. So I can make any modifications here. It's still very much a process that keeps the person in the loop. So we want the experts to go in and do any editing that's needed with these building footprints. So I can see if there are some buildings that need to be assigned to a different territory. I can look through all of my list here, and the ones that I've selected, it's showing me that if I move these to a different territory, then the enumeration area they're currently in, number 264, will go from having 105 total buildings to 78, and the total units will go from 200 to 173. And it's throwing a flag there because that's below the minimum that I set as acceptable for that enumeration area. And I can see, if I move it to the nearby enumeration area, what those new totals will be. So it's very easy to edit this. It is quick to run once you've put in all of your parameters, and then you're able to iterate on this until you have an output that perfectly meets the needs for your areas of interest. So, and again, I'm using building footprints. You could do the same thing with block groups. You can also do multiple levels of it. So I could start with these building footprints, create the enumeration areas, and then I could sort these enumeration areas into additional groups for supervisor areas, or if you want multiple levels of nested groupings here. With that, I'm happy to take questions on this tool. Yeah.
Well, first, I want to know that in each building, can I identify the floors?
So that would be
That is one. One second question is that actually, what is the total number of units? I didn't get that.
Yeah, so for each of these buildings, we included the building number itself and then the number of units. So that's assuming that you've gone out and done some validation for these buildings. So you've seen that there are 4 families living in this one house. So you want to make sure that whoever's coming to survey the house knows that there are 4 families there. It's going to take 4 times as long as if there was only 1 family living there. So that's the kind of thing you can take into account to add additional information to the balancing. If you don't have that information, you could run the same thing just on purely the number of buildings or on the number of floors if you have that information. So that was something that what Saranya was saying before, where you can bring in the DEM information when you're extracting the building footprints. You could supplement that with DEM, or if you have anything like LiDAR data, you can add that 3D information to estimate number of floors in a building, or if you've gone out and done that actual in-person validation, then any information you have, you can add into this system to make it more and more accurate to meet your needs.
Do you have any 3D modeling with the groundwater data and other 3D modeling things?
So 3D modeling for the survey frames?
Yeah, for the urban planning, the groundwater is a major target. So can we have the 3D modeling about the groundwater so that where is the contamination and other things?
Yeah, there's a lot of different projects that people do with 3D modeling. So one that we see some NSOs look into is things like environmental issues or natural disaster concerns. So once you have the building information, it's really powerful to be able to see, oh, if there was groundwater contamination and you have the extent of that, you can see where it would flow downstream with elevation information, and then overlay that with these buildings with the population information to see how many people would be affected. Or different natural disaster planning scenarios, if there's going to be a hurricane or there's going to be landslides, you can try different scenarios and test it against the buildings to see where they're going to be the largest impacts.
All are that is the quantitative. Can you have the qualitative modeling?
So it all depends on the input data that you have. There are hundreds, probably thousands of tools here that based on the specific questions you're trying to answer and the data that you have as inputs. As long as there is some geographic component to either, you're going to be able to do that type of analysis. So we have seen countries do something like this for looking at like refugee camps, so doing tents instead of buildings. And it's going to be as up to date as the imagery you have to start with. So that's something for doing change detection and seeing if there's been a huge movement of people from one area to another. You can recalculate these kind of sampling frames for both areas and take into account whatever kinds of dwellings people are using.
Can we have Mike?
Is there any empirical study or something like that to find the correlation between the units and the population or households in that particular area? For any area, suppose you are getting, say, the highlighted one, the 190 units you have got. What is the expected number of households or persons you are likely to get there? Any empirical evidence or empirical study which shows the very high correlation between units and population or units and households?
Yeah, so off the top of my head, I'm not sure of specific studies. The units in this case is just a proxy for the population. So if you happened to know the actual population in these different buildings and wanted to use that to create your enumeration areas to really know I'm going to survey 15 people at this building, you could do that as well. But in general, you would have to look at data of how many people tend to live in buildings or in family units, and it would be very dependent on the area, I would think.
Apart from the building and total number of units, what else do you collect from there? Any properties, any characteristics of that particular area, of the enumerated area?
So we see other countries do, in their initial survey of the buildings, they'll look at the number of floors, the number of actual apartments. So a lot of times for apartment units, they'll look at the number of mailboxes to get a quick estimation of how many units are in that building. And then if they're trying to do something like a survey of children, they might collect that initial information and do a pre-survey, so seeing how many children live in each building, and then you could balance these based on, we want each surveyor to be assigned to go interview 200 children, and it doesn't matter how many physical buildings they're going to visit, the most important factor is how many children live in each building. So any information that you are going to ultimately need to balance based as you're kind of developing that ultimate survey. You can do pre-surveying to add that information. And in terms of what you can get from geographic information, it's, for the most part, we say it's what you can see with your eyes. So when I'm looking at the satellite imagery here, I can see the building rooftops. So I'm able to extract the buildings. Sometimes you can see, looking at the imagery, that this is a multi-story building. So if I'm able to look and see the rooftops for commercial or for larger buildings look differently to my eye, then I could train the model to do that differentiation. And then you can start getting even more of a head start of trying to just look, putting your residential buildings into this, or just your commercial buildings, depending on what kind of survey you're looking to do.
Thank you, Ms. Kate, for such an interesting session and live demo. Thank you so much. So moving ahead with the next session is a panel discussion for which I would like to request respected Ms. Sunita Vaskar ma'am